Kishore Kumar 260. Kishore Kumar 260. Are you there? Oh, 196. Sundrapandian 196. Are you there? Voice is my voice is audible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, man. Okay. Where is 196, man? Absent or what?
Absent, sir.
One. Then 260.
Sir, present
Kishore
sir.
Kumar.
Sir, இருக்கேன் sir.
The last class இது நீ டெஸ்ட் எழுதியாட்டு இருக்கு.
சார் ஆப்சன்ட் சார் இங்கே ஷட் டவுன் சார் பவர் கட்டுங்க சார் அதனால் வர முடியலைங்க சார்.
சரி, ஓகே.
ஓகேங்க சார்.
But shall we start our class, man?
Yes, sir.
Yes, sir.
Yes, sir.
Boys, do you find any difficulty in my class, man?
Nothing else, sir.
Okay. We'll go to our class right away. Boys, have you noticed, man? We have completed introduction, process, classification, merits and demerits. We have finished. Comparing our additional manufacturing with the conventional manufacturing process. We have compared our AM with CNC. Its application we have completed. CAD data formats we have completed last class, and data translation we have completed. So what are the data loss? It will happen when you do a low resolution, and if you do a high resolution, what will happen we have seen. So only STL format we need to complete in the unit number 1. So I think we are going a little bit faster. Maybe not faster, man. The unit 1 is about brief introduction about overall additive manufacturing. So we are going a little bit earlier in few topics. That's it. Okay. When we go to unit number 2, for each day we will complete one process, I think so. One techniques, I think so. Okay, man. So don't feel that I'm going very fast. I don't know how many of you are listening and how many of you are putting your mic off and they are going somewhere. I don't know. Try to listen, please. Okay, boys. We'll go to our subject right now. We have seen this already. Only last class, what you have seen, I will go as a revision, as a quick revision. I will do. So last class, what I have seen, we have again seen the comparison of additive manufacturing and CNC in 5 different areas. That is material, speed, complexity, accuracy, and then geometry. After that, programming we have compared. In almost all areas, additive manufacturing will win. Only in few things CNC will wins over additive manufacturing. Simply by cost price, CNC will win over additive manufacturing. For each and every product, cost is an important thing for a customer, because most of the customer will care about the cost of a product, then the luxurious or comfortableness of the product. That is why cost plays a main role. Here, the CNC will wins over additive manufacturing overall in cost price. But in near future, I think additive manufacturing will overcome even the cost price also. Okay. Then we have seen with this example, we have seen how CNC will be tough in making a simple product, but 3D manufacturing, ordinary 3D manufacturing will do. For making this cup, we have many different process to make the manufacturing process to make this cup. But when you do in a CNC machine, at least we need a 3-axis machine. But when you do in additive manufacturing, doesn't need any special type of machine. An ordinary 3D printing machine will do this process. Okay, it doesn't need any special tool radius, specially finishing machine, doesn't need anything. Simply it will finish. That is the main advantage of additive manufacturing. And application, I have told you about everything I have told, and few things we have discussed. Especially I have told you about how this 3D printing or else additive manufacturing is used in textile area. So this is how they have used some flexible plastics. They might be used, polymers might be used in dresses. That is what I give an example here. And medical field, they can use easily some complex shapes. It can be done easily without any additional cost. For dental, I'm sorry, I forgot the word. I think prosthetic or orthotics, we can be used directly. Also an important point. Some engineering products. So what is the CAD data format we have? CAD data format means we can have only three formats. We can step file, STL file, and IGS. In these three, when you compare these three, you can choose which one is the best. And we have compared, and we know that step file is best. But even though we are mostly using STL file because it is globally accepted, and even all type of additive manufacturing machines or 3D printing machine accept STL file. Even it is an open source file. That is why STL files are almost all area we have used. But still, in theory wise, step files are comparably better than STL file, because STL file does not carry about the geometric units, but step file it will carry. So once the file carry the geometric units, it is easy to modify or resize when you want to do a modification. But in STL file, it is very tough. That is what the difference is. And even STL file, you cannot carry the textures and colors. Okay, that is what the main disadvantage of STL file. In CAD model, there are two type of groups are there. One is solid, we can save, and one is mesh. One is completely solid, as you're doing in CAD lab, and next one is mesh. While doing analysis, we do a mesh. That is why the two things we can do, and it can save in different file formats. As I told you in yesterday's class, next one is comparing these three, and least choice is IGES, because they have stopped supporting this file, and nowadays they are not using this. So it is a least supporting file. Second one is STL file. And the best one is the step file. Okay, best one is the step file. Here there are two type of STL files. One is ASCII and binary. So these are the two types of file. We will see which one is better in which in STL file itself. Which file is better? We will see by today itself. And I told you earlier, the ASCII is a larger file, so lightly used, and binary file is a compressed file, so it is mostly used. I told you already. So resolution is also important thing, which will finalize how much data will carry over. When you give too much resolution, there will be carrying of data will be more. When there is a low resolution, you will find that your product is a faceted. That means likewise, and many face will come within the product, and when it is a proper resolution, you will get a right material with low data file. Okay, man. When you have to save your file, or when you have to think about your file, you should be alert. You should be alert on two things. One is caudal deviation and angle control. You should be alert, because caudal distance or caudal deviation is nothing but the distance between the stereolithographic triangle and the part surface. It should be as minimum as to have an accurate product. And also, second one is angle control of a mesh of a triangle what you have formed. It is nothing but when you have a curved surface, the triangle will be flat, but when you have many number of triangle, it will make a flat triangle, but finally you will achieve your curved surface. So you have to control these two to have an accurate product. Okay, output, we can say it as output. And also we have seen for SolidWorks what you have to maintain a such thing, or what you have to do in SolidWorks, and what you have to do in Inventor, and what you have to do in Rhino. So this is what we have seen on last class, and today's class we will see what STL file contains. STL file, we'll let us see something detail about STL file. Okay, this slide shows that what is the path for additive manufacturing. When you have a physical model, you can convert into STL conversion, and conversion of part geometry, finally you can print. Or else if you have an image of the object, you can convert into STL form. How this is possible is, now we have a software. When you have an image, you can be converted into 3D model, and this 3D model can be saved as a STL format, and it can be printed. Or else if you have any special design idea or specific design idea, you can develop a 3D model, convert into STL format, and the necessary data you can add, and finally you can print. So this is the general path of additive manufacturing for STL format. Okay. See, when you're going to study about STL format, you should know about what you mean by slicing. Anyone tell me what you mean by slicing, man?
The file sliced in a number of layers and then it's going to feature.
Yes. Good Google. As you have seen in TBI, a CAD model will be sliced as many number as possible, and it will be printed. So the first thing you should know about STL file is it will mathematically split into same layers as many as possible. So this is called slice. Okay, this is called slice. So basically, this is an important thing. Yeah, STL format file, it will slice as many as possible, and similar layers it will be. Each and every layer will be similar. That is what called slicing. Okay, there are two basic methods of doing this. One is triangulation, which leads to STL format. And next one is direct cutting in the CAD system, which leads to SLI format. But SLI format we never uses. Many data, the SLI format, which will not carry when compared to STL format. So we are not using SLI format, but directly we can use in CAD system, but we are not using only STL format. We are using that. Okay. See, STL means, I have already told you, it is nothing but stereolithography, but actually it have other name also called standard tessellation language. STL, standard tessellation language. Also it is called as standard triangle language. Why it is called standard tessellation language means we are slicing into as number as possible. That is called tessellation. Also, this meshing what we are doing here is in a triangular manner. Hence, this format is also called as standard triangle language. Okay. What is the main purpose of STL format is it encodes the surface geometry of a 3D object. It will encode. This is the main purpose of a STL format. Okay. It encodes in the form of tessellation. So the tessellation meaning will be the same. It is a process of tiling or slicing a surface with one or more geometric shapes. Okay, tessellation can involve simple geometric shapes or very complicated. So the thing is, tessellation means in general way slicing a surface with one or more geometric shape. It might be on any shape. It might be of any shape. That means it's not necessary in a professional shape manner. Any type of shape, any different shapes. Okay, these are some shapes of tessellation. See, it doesn't need any professional shape. Any shape can be used. But in STL format of a 3D printing machine, we always use triangle tessellation. This is how it will be. So this is how it will be. Even when you search in net, when you go to images and search in net and shapes of a tessellation, some 3D parts are tessellated in these shapes also. You can even see that. But in STL format, we'll use only triangle. Okay. Why? Because the simple thing is the triangle which we need have 3 vertex. You can easily store the data. But when you take any other shapes here, there are many data you need to store. See, if this is a triangle, you will have 1, 2, and 3. Three vertices will be. But when you take this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is very tough, man. When you take this shape, you need to have a 12 vertices are there. So 12 point you need to store. Finally, what happens is your data will be more, your transferring of file will be very tougher. So each and everything it will be. When you take a star 1, 2, 3, 4, 5, 6, 7, 8 vertices are there. So likewise, when you take a shape, that should be as easy as possible to store data, and it have to carry the more data about the geometry. That is why we have chosen, or else the STL file have chosen triangle as its shape, or else triangle as its tessellation. Comparing valid and invalid tessellated model. Okay, don't think about what it is 6.7, 6.8. I have taken from some random book, man, to comparing valid and invalid tessellated model. This is a 3D shape, and it is sliced as many as possible in a similar way, and that sliced is converted into 1D line. So this is the valid tessellated model. Okay, the second one is, see, it is an invalid tessellated model. Is here they have left some gap while tessellated, so it is invalid, and it is being sliced in an uneven manner. So it starts from middle of the shape, so it is wrong. And third one is, in 1D scan, it have even scanned the outer area. It went out, so it is invalid. So this is the right path, and these are some room for making error. It should be avoided. Okay. Exploiting tessellation to encode surface geometry. So the basic idea is to tessellate the 2-dimensional outer surface of 3D model using tiny triangles, as I told you earlier, and we can store information. See how solid is converted into or tessellated as many as triangle. Take a cube here, man. A cube have a 6 sides. So each side they are converting into 2 triangle, and finally it will have 12 points, or 12 points you need to store. So that is why you have a 12 here. Okay. When you make a tiny triangles as many as possible, you will have some accurate product. So when you take a shape of sphere here, see, you can see a lot of tiny triangles are there. Even though these triangles are flat, in a curved area, the tiny triangles make the curved area in a flat manner, but it will bring in a good output. That is why we will make a tiny triangle. Okay, this is an example of a complicated 3D shape. It is a shape of a pig, and this is how the tessellated triangle will be. Even very tough shapes are easily tessellated. That is why, see, each and every part they have tessellated very nicely. So this is how the tessellated will be, and this and how much easy it is. Look here, man. So any type of 3D can be done very easily. Okay. How does STL file store information? Now we know about STL file. It is one of the best file to store data of a 3D CAD model for printing, 3D printing in 3D machine. Then in STL file, there are two types: ASCII and binary. We will choose binary because ASCII will carry more data, so that we will choose binary. Then we know about what is slicing, how it should be sliced, how invalid should be avoided, and we know about the triangle, how easily we can do in even a tough model. Now we should know about how the STL file store information about facets, as about this triangle. Okay, in both ASCII and binary encoding or binary, both will need a coordinates of the vertices and the unit normal vector of the triangle. These two data is necessary for both type of STL file. Okay, this is a common data, but think how it differs. Let us see that how CII and binary differs. Let us see. See, before going into that, we should know about what is vertex and what is normal. See here, a common point of two rays or two line segment is called as vertex, and more than one vertex will be called as vertices. Normal means perpendicular to the triangle, that is called normal. Okay, see the ASCII file. ASCII means American Standard Code for Information Interchange. American Standard Code for Information Interchange standard file format. So this is how it will be stored. A solid name you will give, facet normal, N means normal here, X, Y and Z. For three vertices you need normal and vertex of each X, Y, Z. And vertex of each X, Y and Z. So 1, 2, 3, 1, totally you need 12 points need to be stored here. So what happens after that? It will end. So what happens is it need many small triangle and it will need more data. So to compact that, we have a binary version. See, this is the program, or this is a method to be followed in a ASCII format. Starting, then input ASCII STL format model, slicing, calculation of inner points, calculation and collections, then whether it have completed all or not. If you completed, we go to next step. It have to be smoother contour. If not, it will go again. Once it have done, it will go next time. And the generation of triangular mesh, once it have done, it go to next step of changing the angle, or that means reducing the distance of caudal deviation, and the angle it will reduce, and finally it will generate the ASCII format. So this is how it will be. It won't take much time. It will done less than a minute, and it will give you the result. So this is the format it will works, man. So when you take a ASCII, you need many data to store. But here how it changes. See, in binary STL file format, there is a header will open here. So in that we will store many data with the many data we can store with the less byte. So normal vector for each and in 80 header we can store up to 80, so we can store all this data simply. Okay, int means integer here, so we can store simply, so the amount of storing data will be reduced here, nothing different than that. So that is why we can choose binary STL format. Okay, binary STL format as a better compared to ASCII. Okay guys, next one is special rules for the STL format. So 4 special rules that we will follow, man. Vertex rule, orientation rule, positive octant rule, and triangle sorting rule. These rules must be followed in STL format. Why we are following this is to reduce the amount of data to be stored here. Data means the size of data. Size of data to be reduced. That is why we will use these 4 rules. First one is each and every point it have to be shared. Each and every triangle must share 2 vertices with its neighboring triangles. So this is wrong one. This is correct. So each and every point, every vertices must share 2 vertices at least. So that is why that when you do like that, when it does like that, the amount of storing data will be reduced. It will be recalled. It will be same, so that it will be the data will be reduced. That is why we will follow the vertex rule. Next one is orientation rule. Orientation rule means the number should be always counterclockwise, and the normal should be from it should be outwards. The normal should always point outwards. That is the second rule we'll follow as a orientation rule. And third one is all positive octant rule. See, if we have negative, the data will be stored from positive to negative. That is why to reduce the data, we are using all positive octant file. See here, 1, 2, 3, 4, 5, 6, 7, 8. So the data will be stored here. It will store only in positive way, so that it will be the data used will be reduced. Next one is triangle sorting rule. See, this triangle sorting rule, they have given us a ascending Z value order, but it is not forced to use. Not necessarily it is always using. Sometimes we can use, but then as a rule it is there, triangle sorting rule, but not always we are following here. Okay. Next one is how is the STL file 3D printed? Let us see this STL file 3D printer as next class, because I want to take something deep in this topic. It will take some 30 minutes. So let us stop here, and I want to ask you that whether any doubts are there, man. Boys, any doubts are there? Any doubt?
No, sir. No, sir.
Really, man? So I will tell you few numbers. What you do, you open your camera and show your notes, man. Okay. Just I want to check randomly. For roll number 40, Ilango, show your notes, man. Ilango, you're doing something, but you didn't show notes. Yeah, Ilango, tell me.
Sir, 3D printing, sir. Introduction,
Show your, I didn't see, man.
no visible, sir. Visible, sir.
It's not visible, man, for me.
So now
Okay, let it be. Let it be. I will ask other person. Roll number 62. Hariharan P.
Sorry, sir.
Show me your notes,
you know
man.
what?
Sir, is it visible, sir?
Yes, man, visible. Thank you, man.
Okay, sir.
One 31. Mr. Reddy, Pavaneshwar Reddy.
Sir, I didn't took the notes, sir.
Why Pavaneshwar?
Sir, from tomorrow onwards, we will take.
So what I will do, boys, today I will send the PPT by today evening or tomorrow evening. You have to write the notes in your separate note, man. Don't forget,
Okay,
man. Let us check others what they have done. Srinath is there, is absent, right? Right, man? Srinath.
No, sir. It's that 281 now.
So 281 is present, sir.
280.
Sir, irka, sir.
Srinath. Srinath, where are you, man? Srinath. Srinath, are you there, man? Boys, attendance collectorல 24 members தான் காட்டுது.
39 are there, sir.
39 are there, but it is showing only 24, man. 27 right now. It is showing 38. I have downloaded now. 39.
Sir, almost 39, sir.
Yeah, okay, man. 39 means if you include me, 39 or else 38. It is showing 38. I have downloaded.
Sir.
Okay, guys. As usual, I will assign test right now. You will do. Any doubts, man? Any doubts?
Nothing, sir.
Okay, then thank you, boys. I will assign right now. Boys, I have assigned. Once you complete, you may tell me and you may log out, man.
Okay, sir.
In between, if you have any doubt, you may ask me, man.
Sir, completed, sir.
Okay, man. Once you complete it, you may leave, man.
Sir, one doubt, sir. நேற்று ஒரு டெஸ்ட் அட்டன் பண்ணோம்ல, அதாவது லாஸ்ட் கிளாஸ் ஒரு டெஸ்ட் கொடுத்தீங்களா சார்?
லாஸ்ட்
கிளாஸ்ல ஒரு டெஸ்ட்ல ஒரு ஃபர்ஸ்ட் क्वेश्चन வந்து 3D டூல் மாடலை வந்து ஃபினிஷ் பண்றதுக்கு எத்தனை ப்ராசஸர் வேணும், ஃபினிஷிங் ப்ராடக்ட்டா வெளில வரதுக்கு எத்தனை ஸ்டேஜஸ் இருக்குங்கிற மாதிரி ஒரு क्वेश्चन கேட்டிருந்தீங்க சார்.
ஆமா ஆமா ஆமா.
அதுக்கு சிங்கிள் ஸ்டேஜ்னு ஆன்சர் வந்துச்சு சார்.
சரி
சார், அது ஃபர்ஸ்ட் ஸ்டேஜ் கேட் மாடல் மட்டும் இருந்தா போதுங்கிற மாதிரியா சார்? அது என்ன மீனிங்னு தெரியல. எப்படியும் ஃபினிஷ் பண்ணதுக்கு அந்த எக்ஸ்ட்ரா இதெல்லாம் ரிமூவ் பண்றதுக்கு ஃபினிஷிங் ப்ராசஸ் சொல்லுவாங்க தானே சார்?
அது क्वेश्चन ஒருத்தர ரீட் அவுட் பண்ண முடியுமா திருநாவுக்கர் சார்?
1 minute சார். In additive manufacturing, how many stages to have a finished product?
Okay. How many stages we have a finished product means once you have a CAD model, you can just print it over. That's it. Adana.
சார், ஆனால் ஃபினிஷ்டு ப்ராடக்ட் மீன்ஸ் அந்த இப்போ அந்த சப்போர்ட் இல்லைன்னா அதுவே ஒரு இன்னொரு மெட்டீரியல் சப்போர்ட் மெட்டீரியல் ஒன்று பண்ணும்ல சார், அதை நம்ம ரிமூவ் பண்ணுறதுக்கு இன்னொரு ப்ராசஸர் பண்ணுவோம்ல சார், ஃபினிஷ்டு ப்ராசஸரா?
இப்போ நீ சொல்றது வந்து ரைட் திருநாவுக்கர் சார். அதாவது எப்படின்னா, இப்போ நான் சம் ஷேப் செய்யும் போது கண்டிப்பா வந்து சப்போர்ட் வந்து எனக்கு தேவை. அப்போ நான் சப்போர்ட்டோட தான் ப்ராடக்ட் வந்து ஃபினிஷ் பண்ண முடியும். அப்போ நான் அந்த சப்போர்ட் எடுக்கும் போது அந்த ரிமூவ் பண்ணும்போது நான் ஃபினிஷிங் ப்ராசஸ் பண்றேன். அதர்ஸ் நான் ஒரு ப்ராடக்ட் வந்து ஆர்டினரியா ஒரு ப்ராடக்ட் பண்ணேன்னா நான் ஃபினிஷ் பண்ண போறேன். அப்போ வந்து மினிமம் வந்து எனக்கு வந்து 2 ஸ்டேஜஸ் ஆகுது. ஏன் வந்து அப்போ 1 ஸ்டேஜ் ஆன்சருங்கிறது வருது அப்படின்னு வந்து நீங்க கேட்குற. இப்போ சப்போஸ் நம்ம இங்க கேட்கறது வந்து என்ன அப்படின்னா, இங்க நம்ம கேட்கறது மினிமம் அப்படிங்கிற ஒரு கொஸ்டின். சரியா? மினிமமா ஒரு ஏஎம் ப்ராசஸ்ல எத்தனை ஸ்டேஜ்ல வந்து முடிக்க முடியும் அப்படிங்கும் போது ஒன்லி 1 அப்படிங்கிற ஆன்சர். மினிமம் அப்படிங்கிறது நீ அண்டர்ஸ்டாண்ட் பண்ணிக்கும். ஸோ மினிமம் வந்து இப்போ நீ ஒரு கப் அப்படின்னு எடுத்து நம்ம எக்ஸாம்பிள் பார்த்தோம், கப்புன்னு எடுத்துட்டோம். அந்த கப்புக்கு வந்து பாத்தீங்கன்னா ஜஸ்ட் லைக் தட் நம்ம வந்து பிரிண்ட் பண்ணிட போறோம், அவ்வளவுதானே? கரெக்டா? அதுக்கு வந்து எந்த சப்போர்ட்டும் தேவை கிடையாது. ஸோ அப்படி வந்து நம்ம மீனிங் எடுத்தோம்னா மேபி உனக்கு வந்து ஒரு வார்த்தை ஆட் பண்ணியிருந்தா உனக்கு டவுட் வந்திருக்காது, அப்படித்தானே?
ஆமா சார், அது ஒன்று சார். கேட்டது வந்து இந்த ஒன்னுங்கிறது எந்த ப்ராசஸர் கேட் மாடலுங்கிறது தானே, அதுதான் சார் நான் கேட்டேன்.
இல்ல ஒன்னுங்கிறது வந்து டு ஹேவ் how many stagesனா only 1 stage. In additive manufacturing, once you have a model, you just print. That is the 1 stage you need to complete. Printing அப்படிங்கிற ஒரு ஸ்டேஜ் மட்டும்தான். Here
ஒன் ஸ்டேஜ்ங்கிறது எந்த ஸ்டேஜ்ங்கிறது தான் சார் நான் கேட்டேன்.
வேற என்ன ஸ்டேஜ் அப்படின்னா பிரிண்டிங் ஸ்டேஜ் மட்டும்தான். when you take when you இப்போ நீ வந்து சிஎன்சி எடுத்துட்ட அப்படின்னா ஈவன் சிஎன்சிலயும் வந்து நம்ம சிஎன்சில ஒரு ப்ராடக்ட் பண்றதுனாலும் கேட் மாடல்ல நம்ம டிசைன் பண்ணி அதுக்கப்புறம் வந்து நம்ம டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் வியூவை பிரிண்ட் அவுட் எடுத்து அப்புறம் நம்பர் ஆஃப் பார்ட்ஸை செப்பரேட் பண்ணி அப்புறம் ஒவ்வொன்றா தானே நம்ம பண்ண போறோம். ஸோ அதுக்கு வந்து நம்பர் ஆஃப் ஸ்டேஜஸ் வந்து அதிகம், இதுக்கு வந்து மினிமம். அதுதான் வந்து கொஸ்டின்.
ஓகே.
எனி அதர் டவுட்?
இல்ல சார், நோ சார்.
ஓகே, தேங்க் யூ திருநாவுக்கர் சார். எனி அதர் டவுட்?
Sir, finished, sir.
Okay, Hari, you may leave, man.
Sir, but one doubt, sir.
Please, man.
Sir, finished, sir.
Store.
Okay, pa.
Sir, information store பண்றது ASCIயா இல்ல வந்து இதுவா சார்? நான் வந்து ASCIன்னு வந்து நினைச்சிட்டு அதை போட்டேன் சார், அது ராங்னு வருது சார். இது சார் பெட்டர்.
எஸ் சார், சேம் டவுட் அதே தாங்க சார். நானும் ASCI தாங்க சார் போட்டேன்.
ஒரே நிமிஷம் நான் பாக்குறேன் என்ன கொஸ்டின், ஒரு நிமிஷம் பார்த்துட்டு உனக்கு ரிப்ளை பண்றேன்.
Which STL format is better to store information, sir?
Which STL format is better? நீ என்ன ஆன்சர் கொடுத்துருக்குற?
ASCII, sir.
அதாவது STL ஃபார்மேட்ல வந்து STL ஃபைல் ஃபார்மேட்ல வந்து 2 டைப் ஆஃப் ஃபார்மேட்ல நம்ம ஸ்டோர் பண்ணலாம். ஒன்று ASCII, அமெரிக்கன் ஸ்டாண்டர்ட் கோட் ஃபார் இன்ஃபர்மேஷன் இன்டர்சேஞ்ச். செகண்ட் ஒன் வந்து பைனரி. சரியா? ரெண்டுலையுமே வந்து ஸ்டோர் பண்ணலாம். ASCII அப்படிங்கிறதுல if you want to store data, you need many data need to be stored. ஸோ ஒரு ட்ரையாங்கிள் பற்றி நீ ஸ்டோர் பண்ணணும்னா அதுக்கு மெனி டேட்டாஸ் வேணும். எப்படி மெனி டேட்டாஸ் வேணும் அப்படின்னு பார்த்தீங்கன்னா, ஒரு வெர்டெக்ஸ்க்கு XYZ எடுத்து அந்த XYZக்கான வெர்டெக்ஸ் அண்ட் இட்ஸ் பாயிண்ட் வேணும். பட் அதே வந்து நீ பைனரியில எடுத்துட்டீங்கன்னா அந்த ட்ரையாங்கிளோட ஒரு வெர்டெக்ஸ், அதாவது 3 வெர்டெக்ஸ், ஒரு நார்மல் இருந்தா போதுமானது. அந்த நார்மல் வந்து பாயிண்ட் டுவர்ட்ஸ் அவுட்வர்ட். ஸோ அந்த டேட்டா வந்து என்ன ஆகுது அப்படின்னா, ASCIIல நிறைய டேட்டா தேவைப்படுது, பட் வந்து பைனரியில கம்மியான டேட்டா தேவைப்படுது. இப்போ ஒரு ஃபைலை நம்ம ஸ்டோர் பண்ணணும்னா யூ நீட் டு ஸ்டோர், யூ நீட் டு ரெடியூஸ் as many data as possible. I mean as many as byte you need to reduce, man. ஓகே, அப்போ நீ கம்மியான பைட்ல நிறைய ஜாமெட்ரிக் டேட்டா ஸ்டோர் பண்ணணும்னா எதுல பாசிபிள் அப்படின்னா பைனரியில தான். அதனால தான் பைனரி வந்து ASCIIயோட பெட்டர். நான் சொல்ல வந்தது உங்களுக்கு புரிஞ்சா?
ஓகே சார். இப்போ பைனரியில தான் அந்த ஹெட்டர் ஃபைல் இது யூஸ் பண்றோமா சார்?
பைனரி தான் ஹெட்டர் ஃபைல் ஓபன் பண்ணி பண்றோம். இப்போ எப்படி சி லாங்குவேஜும் பைத்தானும் எப்படி நம்ம டிஃபரன்ஸ் ஃபைண்ட் அவுட் பண்றோம்? சியும் லாங்குவேஜ் தான், பைத்தான் வந்துங்கிறது சி பேஸ் பண்ணி தான் பைத்தானும் வருது. பட் என்ன அப்படின்னா இந்த டேட்டா ஸ்டோரேஜ் வந்து பைத்தான்ல வந்து உனக்கு மாறும். அப்போ உனக்கு என்ன ஆகுது அப்படின்னா ஆர்டினரின்னு சொல்லக்கூடாது, சிம்பிளா நம்மளால என்ன பண்ண முடியுதுன்னா ஒரு ஆப் வந்து நம்ம ஒரு செல்போன்ல, அதாவது ஆண்ட்ராய்டு மொபைல்ல ஒரு ஆப் ஈஸியா பண்ண முடியுது. பட் அதுவே சில பண்ண முடியாது, ஏன்னா டேட்டா நிறைய எடுக்கும். அந்த மாதிரி தான் இதுவும். சரியா?
எஸ் சார். ஓகே சார். தேங்க்யூ சார்.
Thank you, sir.
Boys, any other doubts? Okay, if you complete, you may leave, man.
Sir, completed, sir.
Okay, man. Okay.
Thank you, sir.
Completed.
Thank you, man. Okay, man. Okay.